All right, this is the spreadsheet for the simulated turning design of experiment. And notice that we have a set of circumstances here where we have our factors laid out: surface speed, feed rate, depth of cut, the density of material, which is not going to be changed. We have placeholders for insert cost, number of edges, and tool life, and that's going to be dictated by the type of tool that's selected, whether it's tool 1, 2, 3, or 4. Coolant cost, coolant amount, labor cost is fixed. So when you go to lay out your experiment, the first thing is to look at these min and max values and determine the level settings that you want to have for the different factors. You also want to think about, are any of these factors potentially going to have a combined effect or an interaction based on the physics. So we've gone ahead and we've decided that there are going to be some combined effects, and we've designed a 16-run Yates algorithm experiment, and this is what the layout looks like. Here's our settings for the low setting and the high setting for each of the factors, and then based on the experiment design, this is what it looks like, all the 16 runs. So what you will do is you'll take a particular condition. All right, let's say it's experiment run number 1, and we'll put that into our simulator here. And so we would have a speed for experiment run number 1 of 100. We would have a feed rate. All right, you can see already the cost per pound of material removed has changed. The feed rate is 0.01, which is the same. The depth of cut is 0.035. All right. The coolant quantity is 0.01. The coolant cost is 0.2. All right. And the tool that we used in this experiment run number 1 was tool number 3. So tool number 3 has a cost of 30. It has 2 edges, and it has an expected tool life of 25 minutes, which is what we have. So now we have all the settings in there, and this is the output that we would then have for that experimental condition. And you can see that's the same one we have here. Let's try condition number 2. All right, so here's condition number 2, and if we come back over here to the simulator, and now I'm going to type in the surface speed, and that's going to be 150. All right, I'm going to move down to the feed rate. It should be at 0.01. The depth of cut is still going to be 0.035. The coolant amount is 0.05. The coolant cost is 0.1. Now the tool that we have for this one is tool number 2, so it's T2, and T2 has a $20 cost, 25 minutes of minimum expected life, and 1 edge. So the cost for that particular tool is $20. It has 1 insert, 1 edge, and its expected life is 25. So there's the output for that particular combination of $7.13 per cost per pound of material removed. So we go through and we do each one of these. These are all of the values from that setup, and then we'll create this experiment in Minitab, add all of our data in there, and then we can do our analysis. So that's how you can use the simulator. Now you can use any experiment design that you want. You can choose as many of these factors that you want to try. You can do 2-level designs, 3-level designs, but you can use this calculator for the simulation of turning to generate an output, and you'll be able to hone your skills on using what you've learned in this course, the Advanced Course in Design of Experiments. You can try the different types of experiment designs that we've shown you, and this is a good way to really get good at not only designing the experiments, but analyzing them and understanding what the results are going to be, as we go to make improvements. So the next step is to take a look at the mini-tab setup of this experiment, and we'll go through the analysis so you can see how it was done. You don't have to use the experiment that we chose, but that's fine. And we'll go from there.